Okay, so we're up to protein. Proteins are made of carbon, hydrogen, oxygen, and nitrogen, with the abbreviations of all capital letters CHON. Protein is the only nutrient that can build, repair, and maintain body tissues. So protein is needed in an adequate supply in a daily diet, and it's essential. All tissues and fluids in the body, with the exception of bile and urine, contain some protein. It's the basic building material. Its basic building material is an amino acid. So all tissue and fluids in the body, except bile and urine, contain some kind of protein. So if you look at a UA and you see that it's positive for protein in the urine, then you know that there's a problem, because that is not normal. You also have to think that when you have a person with a wound, especially a wound that you're trying to heal or that you're having difficulty healing, since protein is the only nutrient that can build, repair, and maintain body tissues, build and repair being the key there, that you need to have these people increase their protein intake to help with that repair and building of tissue from that wound or that injury. So that's why it's so hard sometimes to get people who do not eat properly to heal when they've had surgery or injuries, because they do not have enough protein in their diet to heal those wounds. So keep that in mind. And daily protein requirements are determined by the size, age, gender, physical and emotional conditions. A bigger person with more body cells a bigger person has more body cells to maintain than a smaller person does. So their protein intake is going to be higher than that little person. A growing child, a pregnant woman, or a woman who's breastfeeding needs more protein per pound of body weight than does the average adult. When digestion is inefficient, fewer amino acids are absorbed, and protein requirement is higher. You need to take more in so that you have the chance of getting more protein out of it. That's sometimes thought to be the case with elderly clients. Extra proteins are required after surgery, burns, infection, to replace the lost tissue and manufacture antibodies. Also, emotional traumas that cause the body to excrete more nitrogen than it normally does increase the need for protein-rich foods as well. The National Research Council of the National Academy of Science states that the average adult's daily requirement be 0.8 grams of protein for each kilogram of body weight. So you know how to do the math, figure out their weight in kilograms, and then they need 0.8 grams per kilogram. So it's determined that way as to what the protein requirement is. So the primary function of protein is to provide amino acids, which are necessary for that synthesis of body proteins. Those body proteins are used to build, repair, and maintain body tissues. Protein composes most of the muscles, skin, hair, nails, brain, nerves, and internal organs. So if you think about a lack of protein in the diet, all of the things that it ultimately affects. Another function of protein is assist in regulating fluid balance. Proteins are vital parts of enzymes, hormones, and blood plasma. Many body processes are regulated by those enzymes and hormones. Proteins are also used to build antibodies, and antibodies help defend the body against disease and foreign substances. So proteins play incredible functions in the body. In the event that insufficient stores of carbs and fat are lacking, protein in the form of amino acids can be converted into glucose and used for energy. That's gluconeogenesis. That's the conversion of protein in the form of an amino acid into glucose for energy, gluconeogenesis. However, When you have to use those proteins for energy, they're not available for their primary function, which is that building, repairing, and maintaining body tissue. So if there's a diet that is adequate in protein, but is lacking in carbs or fats, then protein is used for the energy and not for what it's necessary for, or what it's needed for its primary function. Using protein for energy also results in waste products that are difficult for the kidneys to excrete. The kidneys have a hard time with protein. So if you're having to use kidneys, Lord help me, if you're having to use protein for your energy source, the kidneys are having difficulty filtering those byproducts out. And that's not good for that, because so now you've got a reason for the kidneys to not function the way they're supposed to be either. We'll talk about it when we talk about renal diet. So think about that in patients who have renal failure, either acute or chronic renal failure, and what kind of diet they should have. Proteins are also classified by source and completeness. Animal sources, of course, meat, fish, poultry, eggs, milk, dairy, anything that comes from an animal. And then plant sources are grains, legumes, nuts, and seeds. Completeness of proteins refer to the quality of the protein. Of the 22 amino acids, 9 are essential, which means that they must be present in the diet because the body cannot synthesize them. Complete proteins then contain all of those 9 essential amino acids. All animal proteins, with the exceptions of gelatin, are complete. The only complete plant protein is soybeans. So plant proteins then are incomplete. They are lacking one or more of those essential amino acids. Those plant proteins can be combined in one or more to give all the essential amino acids that are necessary. Some of the things that are complementary plant proteins: rice and beans, corn and beans, wheat bread and beans, toast and pea soup, and then rice and lentils. And these complementary proteins are very important when you're planning a vegetarian diet, to make sure that you get all of the essential amino acids in there. Chemical digestion of proteins begins in the stomach. Most of the digestion itself, though, takes place in the small intestine. The end byproduct is an amino acid. The body takes those end byproducts of amino acids and uses them to build, repair, and maintain. Do you see a trend here? Build, repair, maintain. The amino acids are absorbed into the blood via the intestinal mucosa, and those that are not used to build proteins are converted to glucose, glycogen, or fat and are stored. So right now you need to know what the process of gluconeogenesis is, classification of incomplete and complete proteins, and what the daily requirements are per kilogram of body weight, and the functions, what the functions of proteins are. No more than 15 to 20% of one's daily kilocalorie intake should be of protein. When people don't have adequate protein in the diet for an extended period, muscles waste, with the arms and legs becoming very thin. At the same time, though, their albumin deficiency causes edema, so they appear extremely swollen. they take in adequate protein, the edema goes down. Edematous patients tend to be very lethargic and depressed. And in third world countries where children are neglected or the elderly are poor and incapacitated, you have this tendency to be edematous with this lethargy and depression. Children who lack sufficient protein don't grow properly. Infants born to mothers that have insufficient protein in their diets during pregnancy have permanently impaired mental capabilities. And two of the greatest things for children caused by grossly inadequate supply of protein, energy, or both is marasmus. And it's a condition that results from severe malnutrition. It afflicts the very young who lack both the energy and the protein foods, as well as vitamin and minerals. They appear emaciated, but they do not have edema. Their hair is very dry and dull. The skin is thin and wrinkled. Kwashiorkor is also a protein deficiency, but there's a sudden or recent lack of protein-containing food, such as during a famine. It results in edema, painful skin lesions, and changes in the pigmentation of the skin and the hair. So marasmus is a condition from severe malnutrition. Kwashiorkor is a sudden or recent lack of protein-containing foods, like a famine. It's hard for us to imagine sometimes that this would be possible because we live in a very developed country. Third world countries, this is quite common for kids. In our part of the world, we tend to ingest more proteins than the body needs. Excess proteins can contribute to heart disease and provide more kilocalories than needed. There have been some connections between long-term high-protein diets and colon cancer and high calcium excretion, which in turn depletes bones of calcium and may contribute to osteoporosis. People who ingest excess fruits and vegetables and excess protein people who ignore fruits and vegetables and eat more proteins tend to stress the kidneys. The kidneys sometimes are not able to process or excrete all the protein that's trying to be filtered through them. This is the next slide are some of these kids that have these protein deficiencies that are afflicted with the marasmus or the kwashiorkor. You can see they're very thin, their bones are protruding, eyes are sunken. It's just pitiful. You can see in that first picture there is the kwashiorkor. It's the protein deficiency. You can see in the bottom picture some of the skin lesions that are on them. And then you see the little skinny arms and the little skinny legs, but the edematous bellies.